Welcome to week 3 of Nino and Calandra's College Algebra Cohort. In today's session, we're going to look at a new type of number and how to perform basic operations with it. Next, we're going to look at all of the ways that you can use to solve quadratic equations. And then lastly, we're going to look at some real-world applications involving quadratic equations. So first, we're going to start with performing basic operations with complex numbers. The set of complex numbers is comprised of real numbers, which we've seen during week 1, the natural numbers, rational numbers, irrational numbers. Any type of number you can think about is a real number. But the type of number we have not discussed yet are the imaginary numbers. So the set of complex numbers is comprised of both real numbers and imaginary numbers. Complex numbers can be written in the form a plus bi, where a is the real part and b is the imaginary part. So the numbers that we've been looking at so far have had this value of I equal to 0 because we haven't seen the number I so far. Well, I is the imaginary number, and it's defined to be the square root of negative 1. This is equivalent to saying that I squared is equal to negative 1. So an important note is that if you have two square roots multiplied together, you can only multiply the radicands, the part under the square roots, together if both are positive numbers. The same applies for division. So if you look at this illustration where we have the square root of negative 2 times the square root of negative 2, this important note is telling us that we cannot change that to the square root of negative 2 times negative 2, which would equal the square root of positive 4, which is equal to 2. We can only do this if those are positive numbers under the square root. Since that is not the case, we have to make sure that we deal with the negative under the square root. Okay, so I can rewrite the square root of negative 2 as the square root of 2 times negative 1. Okay, and I can do the same thing for the second one, 2 times negative 1. Okay, well now I can break this up. This is the same thing as saying that we have the square root of 2 times the square root of negative 1 times square root of 2 times the square root of negative 1. Okay, using the commutative property, we can change the order and do our square root of 2 times square root of 2 times square root of negative 1 times the square root of negative 1. You're not going to have to do all of these steps as you're working through the problems. I just wanted to go through this in this illustration to help you remember. So now that we have two positive numbers under the square root, we can multiply them together. So we get the square root of 4 times, well, the square root of negative 1 is our imaginary number I, so we can just fill that in, times, and we have another square root of negative 1, which is equal to I. So now the square root of 4 is equal to 2. I times I is I squared. We work with it just like a variable. But now we know that I squared is equal to negative 1. So we end up with 2 times negative 1, or negative 2. So notice that negative 2, the correct answer, is not the same as what we would have come up with if we just simply multiplied the values under the square root. Okay, so whenever you see the square root of a negative, you want to make sure to get the negative from outside. Get the negative outside of the square root by using I, so then you can work with your rules. So let's look at a couple of examples of how to do that. So for number 1, we want to write the following square roots in terms of I. So for the square root of negative 5, I can write that as 5 times negative 1. Okay, well the square root of 5, we can break this up. So we have the square root of 5 times the square root of negative 1. Square root of 5 is not a rational number, so we can just leave it as that, times, well, we know the square root of negative 1 is defined to be I. So you can leave your answer as the square root of 5 times I, but just so that it's clear that the I is not under the radical, typically we would write the I before the radical. So I square root of 5, and that way it's more clear that it is not part of the radicand. All right. So notice all that happens when you have a negative under the square root, you end up taking an I out, and then you're left with the number underneath to simplify. Okay, so applying that to example B. The square root of negative 16 means I can take an I out, and I'm left with the square root of 16. Well, the square root of 16 is 4, so we just have I times 4, which we would write as 4I, just like we would if we had x or any other variable. Okay, let me stay consistent with identifying my answers here. All right, going on to part C. Hopefully you know your first step is going to be to take the I outside of the square root. Now 28 is not a perfect square, so we're going to have to simplify that. I know that 28 is the same as 4 times 7. So now I have I times the square root of 4 times the square root of 7. Well, the square root of 4 is equal to 2, so I'm going to write that 2 first before the I. Square root of 7, can't do anything with that, so we just leave that under the square root, and that would be our answer. Okay, looking at number 2, simplify the following. Okay, we want to make sure to use our caution here that I talked about earlier, the illustration. Since we have a negative under the square root, first thing we want to do is bring it outside. So the square root of 4 is equal to 2. For the second square root, we have I square root of 25. But the square root of 25 is equal to 5. So we just have 2 times 5I, or 10I. Okay, going on to part B. Okay, I cannot divide those two numbers under the radical since they're negatives. So our first step is to bring an I outside. So we have I square root of 21 divided by I square root of 7. Okay, well, I divided by I is equal to 1, so those are going to cancel out. And since I now have positive radicands, we can rewrite this as the square root of 21 divided by 7, which will equal the square root of 3. And that would be our simplified answer. Okay, the next example, simplify the following. Write your answer in the form A plus BI. So the way that you work with the imaginary number I is just like you would with any variable. The only difference is if you end up with I squared, you want to make sure that you evaluate it because I squared is equal to negative 1. All right, so to simplify this, we need to first get rid of our parentheses. There's nothing outside of our first set of parentheses, so we have negative 3 plus I. Now we need to distribute that negative, so we end up with a plus 2 minus 5I. Okay, so now we need to combine our like terms, our numbers, and then the imaginary parts. So negative 3 plus 2 is negative 1. I minus 5I is negative 4I. And that would be our answer. So negative 1 is the real part, negative 4 is the imaginary part. Okay, with part B, we have a binomial squared. So hopefully it came to mind that we need to rewrite this as that binomial times itself. Okay, so now we see that we need to apply the FOIL method, or just some form of the distributive property. So we get our first times first, which is 9. Outer times outer is negative 6i. Inner times inner is another negative 6i. Last times last gives us a plus 4i squared. Okay, so I have a 9 minus 12i, combining those like terms, plus 4. Now, I squared is equal to negative 1, so we really have a 4 times a negative 1. So that means we have a 9 minus 12i minus 4. So we can combine our numbers together to end up with 5 minus 12i, and that would be our simplified answer. Okay, next we're looking at a term called the conjugate. The conjugate of the complex number a plus bi is going to be that value, but the imaginary part is going to have the opposite sign. So a minus bi would be that conjugate. So an example, find the product of the number 5 minus 2i and its conjugate. So the first thing we need to do is identify what is the conjugate. Okay, the conjugate means we're taking the opposite sign of the imaginary part. So that's going to be 5 plus 2i. Okay, we're looking for the product, so that means that we're going to multiply these two numbers together. So we have 5 minus 2i times 5 plus 2i. And we can now use distributive property, or the FOIL method, to multiply that out. So first times first is 25. Outer times outer is plus 10i. Inner times inner is minus 10i. Last times last is minus 4i squared. Okay, so we see that the middle terms cancel out, and we can evaluate that I squared. It's negative 1. So we end up with 25 minus 4 times negative 1. So remember, you do multiplication, thinking order of operations. So we end up with 25 plus 4, or 29.